Hello. Today we're going to talk about psychological research methods. This is a basic introduction to some of the research methods we use in psychological research. We'll talk briefly about descriptive research, spend some time talking about correlational research and correlational designs, and talk about experimental psychology. Finish up by how we draw some conclusions, and then talk a little bit about sampling and representativeness and why that's important in psychological research. Let's start by talking about descriptive research. The goal in any descriptive research study is simply to describe a population or patterns of a disorder, individuals, etc. So we're talking about basic descriptive research. So what percentage of high school seniors have smoked marijuana in the last month? Or what percentage of college students engage in safe sex practices? These are basic descriptive kinds of designs. There are several different ways to do a descriptive research. Case studies are detailed descriptions of an individual. Most often, case studies involve unusual injuries, unusual disorders, strokes, that sort of thing. So Oliver Sacks's book, The Man Who Mistook His Wife for a Hat, is a sort of collection of case studies involving things like prosopagnosia, hemispatial neglect, some fairly unusual disorders that he describes in sort of detail how these people function and how their injuries occurred, etc. Other famous case studies include Phineas Gage, of course, famously had a railroad tamping rod travel through his skull, severing the connection between his frontal lobes and his limbic system, causing severe personality changes. These are basic in-depth descriptions of individuals. More often, and probably one of the most common research methodologies, are surveys. So a survey is simply a set of questions we send out to a group of people and have them respond. You've, I'm sure, responded to a number of different kinds of surveys. We do these for our courses. We survey them to see how they like the course. People do surveys to see what kind of breakfast cereal you eat. We do public polling, which is another type of survey. In psychological research, oftentimes we're interested in trying to detect patterns of responses, and we'll talk about correlations and regression analyses here in a minute. So when we construct a survey, oftentimes this is a little bit of art and science mixed together. Survey research is oftentimes difficult because trying to get accurate responses and responses from the right kinds of people, preferably all kinds of people that we're interested in, is difficult. So when we put together a survey, oftentimes you have to think about the competing interests of how much information you want and how long someone's willing to sit and answer your survey. And this is, there's no good answer to this question. I think probably most people have sat down with good intentions to fill out a survey, and halfway through it thought, oh God, how long is this thing going to be? It certainly has happened to me in my life. So I think it's an important question, balancing the amount of content versus trying to actually get people to finish the survey, because people who don't finish the survey don't do you any good. That gets us at the next question, which is sampling. That is, how do we get people into our survey? Well, in the old days, as we call it, we used to do phone surveys. So you'd sort of randomly dial these. These still occur. A lot of public polling still does random digit dialing, or using existing lists of people that they can call. That works to a certain extent. It doesn't work as well as it used to because people don't answer their phones anymore. Certainly they don't often answer their phone if it's a number they don't know. I know I don't. So oftentimes we use email or other internet-based surveys to send out to a sample. So in our department, recently we were interested in surveying our graduating seniors, so we sent out an email to all of our graduating seniors, and I think we got 25 back out of, I don't know, probably a couple hundred or 100 or so, something like that. And so you have to wonder then, when you do this kind of sampling, oftentimes we do targeted sampling, so you might be interested in attitudes about pre-exposure prophylaxis, which is an HIV prevention medication, attitudes about that in the gay community, so you might try to target those people online. or you might try to target a specific subsample. The problem is, though, is getting at that sample, and then you end up with what we call selection bias. So one of the problems with selection bias is the people that respond to your survey may be different from the people who didn't respond to your survey, and that's a huge problem. So recently there's been a number of surveys on campuses about sexual assault that have some serious selection bias problems. I think it's a huge problem we need good, accurate information about, but when you only have 5 and 6% of your students returning a survey, you have to wonder if that 5% is not representative of the rest of your students. And so it's a really important problem to consider whether or not you might have some selection bias. Okay, so that was our introduction to descriptive research. Now I want to move on to talk about correlational research. In correlational research, the goal here is in describing the relationship between variables. So when we take something like a survey, oftentimes we'll take the data and try to determine if there are relationships between variables within that survey or other measurement instrument. So a correlation is simply one in which we mathematically determine whether or not measures are related to one another. So measures that are correlated have a significant relationship with one another. So we'll take a look at a couple of examples like height and weight, intoxication and balance that are correlated with one another. While they aren't perfectly predictable, and that is, not everyone who's 5'8" has the same weight, and 2 drinks isn't going to affect balance the same way in 2 different people. But they are correlated with one another. So this is what we call a scatter plot. So if we talk about how long someone can balance on one foot or on a balance board, and then look at their level of intoxication, you would probably get something that looks like this. The more intoxicated they are, the less time they can actually balance. So as we start to look at these kinds of correlations, we actually calculate what's called Pearson's R, which is a correlation coefficient. Correlation coefficient is always somewhere between -1 and +1. The closer the correlation coefficient is to 0, the weaker the relationship. So the closer it is, the further it is from 0, the stronger the relationship. So 0.80 correlation is a pretty strong relationship, whereas a 0.3 or -0.3 is a kind of weaker relationship. The sign of the coefficient indicates the direction of the relationship. So a positive correlation coefficient occurs when 2 variables move in the same direction, like height and weight. Taller people tend to weigh more. Versus what we saw just a moment ago, which is intoxication and balance, where we get a negative relationship. That is, the more intoxicated, the less balance and coordination ability someone had. So these are the kinds of correlations we might see. Well, you probably never see these, but positive correlation, whereas one variable increases, the other variable increases. A negative correlation, where one variable increases and the other decreases. And then this would be no relationship at all, where there's just simply no pattern of relationship between these 2 variables. More often, this is kind of what our research would look like in a scatter plot. So here we have no relationship. Here is a weak positive relationship. You can see things sort of start to trend towards a positive relationship. Here's a little bit stronger relationship that looks a little bit more significant. Again, starting to cluster more together. And then here we have a highly significant correlation coefficient. One of the problems with correlations is determining causality is something we actually aren't able to do with correlation. So one of the problems with detecting causal relationships is you actually have to conduct experiments. And for a long time, we weren't able to do that for a variety of things. So here's what we call superstitious learning. So for centuries, people sacrificed their enemies to try to get things like rain because they believed there was a relationship between those sacrifices and the weather. This is what we would, of course, call a spurious relationship. From a logical perspective, we often call this post hoc ergo propter hoc, which is Latin for after, therefore, because of it, which is a logical fallacy in which we assume that because one thing follows another, that the 2 are causal, that the 2 are related to one another, when in fact, oftentimes that is not the case. Contrast that with smoking. where we know that smoking causes cancer, but for the longest time we couldn't prove that because all we had was a significant correlation between people who smoked and cancer rates, and it might be that people who smoke have something else that's related to cancer. Now, of course, we've been able to sufficiently establish that, but that's one of the problems with correlations. So again, to take a look at these kinds of relationships, here we would have a perfect positive relationship. These things never occur in nature. Even this high positive relationship is not going to happen very often. This medium positive relationship, far more like what we would expect. This is a low relationship, this is no relationship, and then this would be a high negative relationship. So, one of the most important things to understand about correlation coefficients and correlational research is a correlation on its own never indicates a causative relationship. So to give you an example, this comes from Keith Stanovich's book, How to Think Straight About Psychology. It's a terrific book. It's been used in a number of different courses that I've been involved with, both as a teacher and a student. And this is an example of what we call birth control by the toaster method. And what happened is a survey in another country was interested, the researchers were interested in trying to determine why some people used birth control and others didn't. And so they collected a bunch of data, and they discovered that the best indicator of whether or not participants in the survey used birth control was the number of small appliances they had in the home. Now, you would never go out and start handing out toasters and blenders to try to get people to use birth control, because that's obviously ridiculous. There's obviously something else going on, and what's going on, of course, is the people who have more toasters and blenders and whatnot have more money, and people that have more money tend to have higher levels of education. And that's where the relationship's actually coming from. So this is what we call a spurious relationship caused by third and fourth variables. So questions to always consider or to think about as we continue discussing correlations. You want to make sure you understand what's the difference between a positive and negative correlation. Of course, that's the direction of the relationship. Talk about how correlations can be measured and understand that. And then what does it mean for a correlation to be strong? That just simply means that there is a more close relationship between the two variables. So one of the things we often do as psychological researchers, and in other fields as well, is do what's called multiple regression. And in multiple regression analysis, we're able to account for these additional variables. So for example, in our birth control toaster method, we could actually partial out the effects of other variables and try to determine exactly what the strength of the relationship might be between birth control and education by accounting for other variables like income. If you're interested in multiple regression, some books I highly recommend are the Freakonomics books. They talk a great deal about regression and exactly how you can do some really interesting econometric designs using regression, or simply looking at a standard stats textbook is certainly something to consider. So in this discussion of correlations, I want to get out some really important lingo about how correlations work. The first of these is what we call a spurious relationship. And I've used this term already a few times. And a spurious relationship occurs either because of random chance, that is, two things appear to be related when they're not at all, like sacrificing humans to appease the weather gods. Or in other cases, sometimes there's a spurious relationship like birth control and toasters that is related in some other way. So to give you an example, in 1949 we get a correlation between the incidence of polio and ice cream consumption. And this individual concluded that sugar made children susceptible to the disease, but as it turned out, a third variable, warm weather, caused both an increase in disease and an increase in ice cream consumption. And so this is a spurious relationship. There's no causal relationship, or no relationship really at all, between ice cream and polio, other than that they both occur during warm weather. So that gets us to the third variable problem and what we call extraneous variables. Extraneous variables can be third and fourth variables. That is, these are things that are not part of what we're interested in studying. So an extraneous variable is one that is outside of what we are interested in studying, or is something that is unaccounted for. And it's the same thing with the third variable problem. The third variable problem occurs in a number of instances. Again, we saw this with birth control and the toaster method. Oftentimes, this comes up as well in things like exposure to media violence and aggressiveness. And so, this is just an example, but oftentimes we talk about that there might be some relationship between exposure to media violence and aggressiveness in children. But there might be some third variable that we haven't accounted for, like lack of adult supervision. And so we might oftentimes think about how aggressiveness and exposure to media violence might be mediated by some third variable. Another problem with correlational designs is, while two things might be related, we don't always know the direction between the two. That is, we don't know what variable is causing the other. So, for example, going back to our media violence example, this has been a classic problem in trying to study this issue. Is it that violence in media or even violent video games causes aggression in children, or, so that would be a causal variable in one direction, or is it that more aggressive children prefer violent programming and violent games? That would mean the direction goes in the opposite direction. Another classic example, again coming from Keith Stanovich's book, How to Think Straight About Psychology, has to do with eye tracking and reading ability. And what was discovered is that kids who are having trouble reading did not have the ability to do what we call smooth pursuit eye movements, as well as their colleagues who could read very well. And so the assumption was, well, they can't track their eyes well, so that they're having trouble reading, and so if we can train them how to track their eyes well, they'll read better. And so millions of dollars spent on these eye training devices that train people to move their eyes back and forth, and it turns out that reading was actually causing better eye movements. So the eye movements had nothing to do with reading ability, but reading ability had everything to do with eye movements. And so lots of money spent on a very poor conclusion and a poorly designed study. The last thing I want to talk about has to do with selection bias. And this is a huge problem with correlational designs because they can create the illusion of a relationship that doesn't exist. And a really terrific example of this has to do with SAT and ACT scores. You have to oftentimes think about who's taking these exams. So California, most California schools require the SAT, whereas, say, Mississippi, most of the state Mississippi schools require the ACT. And if you look at per pupil funding for schools, California has some of the highest, Mississippi has some of the lowest. Now, if you use the SAT as a measure of performance, there is much lower SAT scores in California than in Mississippi. And so, oftentimes politicians will say things like, look, California spends all this money and they have lower average SAT scores than Mississippi. The problem is there's a huge selection bias problem, because in Mississippi, only students that are going to private schools or going out of state take the SAT, whereas all students who plan on going anywhere to college in California take the SAT, and it's something like 50% or 60% of California students versus some really small percentage in Mississippi. So the Mississippi schools are selecting only the best and the brightest to take the SAT, because everyone else is taking the ACT that wants to go to Mississippi State. Whereas California, anyone that wants to go to any Cal State school, has to take the SAT. And so they're selecting from a whole different part of the pool. So it's a really important thing to understand where your data is coming from. So if you want to take a little play around with this idea, you can hack your way to glory on the 538 blog, where you can actually play around with different data and come up with correlations using a variety of different kinds of econometric measures. So play around with that. So experimental psychology is where we actually conduct experiments and can explore cause and effect relationships. So this is a research method in which an investigator manipulates one or more factors to observe the effect on some behavior or mental processes as measured by the dependent variable. This allows us to actually establish cause and effect relationships. So here's the logic. If we manipulate some factor and everything else is the same, and we observe some change in our dependent variable, that change has to be due to our manipulation, that is our independent variable. So we'll take a very simple example. Let's say we're going to try to enhance cognition using a drug. So we give one group of participants modafinil and another group of participants placebo, and before and after we use some sort of measure of intelligence like Raven's progressive matrices. And so assuming there's no difference between our two groups and the modafinil group gets smarter, that is they perform better, it has to be due to the drug. Now the problem is making sure that's the only difference. We've got to make sure there's equal numbers of males and females, that they start off at the same level of intelligence. So maybe we give them the Raven's progressive matrices and equate the two groups. That is, we make sure that both groups have the same average performance at the start, and then we see how they improve. Or we can do it within subjects design, where half the participants get the placebo the first time, half the participants get modafinil, and then we bring them back in and we switch them around. And so we are actually able then to compare people to themselves to see if there's an improvement. But the key is there has to be, the only difference is that independent variable, and then any change has to be due to that dependent variable, or any change in the dependent variable has to be due to the independent variable. So an independent variable is the experimental factor that we manipulate, the treatment itself. So in the example I just described, drug versus placebo is the independent variable. There are as many independent variables that you can think of as long as it's whatever you're manipulating. In a previous talk, I've talked about, I have this idea, this belief, that your ability to parallel park is related to the number of people standing around watching. So if you wanted to conduct an experiment in this kind of study, you could manipulate the number of people standing around. So you could have none, and you just observe with the camera, or you have 5 and then maybe 10 people. That would be your independent variable. So in this example, we have a sample we start off with, then we have an experimental group that gets exposed to media violence, then we have a control group that doesn't get exposed to media violence, and we measure their aggression. Dependent variables is what we measure in an experiment, and again, this can be a myriad of different kinds of measures. So a dependent variable is used to measure a construct, and this is a really important distinction to try to understand. So a dependent variable measures a construct. So a construct might be memory. So ask somebody, we want to measure their memory. So that would be a construct, whereas proportion correct in a free recall task would be a dependent variable. So we're measuring memory by using that free recall task. Another example, our construct might be intelligence, and we're going to measure that with the Stanford-Binet, or the Wechsler Adult Intelligence Scale, or the Raven's progressive matrices. So the dependent variable is that measure, whereas the construct itself might be something like intelligence. Confounds are an important thing to consider whenever you're talking about an experiment, as you're designing an experiment or trying to understand or interpret somebody's experimental results. So these are extraneous variables that compete with our independent variable to explain our data. So this is really essentially anything that's screwing up our experiment. So as I was talking a moment ago about the logic of experimental design, in order for us to conclude that the independent variable caused some effect on our dependent variable, we have to make sure that that's the only thing that is different. A confound is something that has gotten in the way of that. We attempt to minimize these by doing things like randomly assigning people to conditions so there's no systematic bias. We use controlled environments so everything's the same, it's quiet, same lighting, same everything. And we try to minimize these confounds wherever we can. Some examples of confounds include things like gender. We end up with more males in one condition than females. Time of the semester. We test group 1 in September and group 2 in December. Lots of different things can be different. We want to make sure we minimize those. So random assignment is an important part of this process. Essentially the idea is we use computers, mathematical models, etc., to assign people to conditions. And the basic idea is that we're not assigning them by ourselves, because we don't want to use selection bias as a confound. There's some classic examples in the medical literature where physicians are allowed to decide who goes into an experimental group and who doesn't. Oftentimes they pick people who are most likely to respond to the treatment, that they think are going to respond to the treatment. They pick the healthiest people. So we want to remove that subject selection as a potential confound, and so we use random assignment. So we have a group of people, and we pick people at random to be in our two groups to make sure that there is a similar number of people across our groups in some sort of aspect. So I want to talk briefly about drug studies because they're an important part of the things that I talk about in my courses, and they provide a really pretty concrete example of how to conduct an experiment. So the first thing you have to understand about drug studies is placebo effects and nocebo effects. And placebo effects occur when people get better because they think they've been given some sort of treatment. And things like pain management and alcohol studies have huge placebo effects. So you have to be very careful how you craft a study and make sure you have some kind of placebo condition, because you want to make sure that whatever drug you're testing has an effect above and beyond those placebo effects. Important also to understand that you can get what are called nocebo effects. That is, people can have side effects because they think they've been given a drug when they haven't. So in modern antidepressant studies, for example, they do what's called the placebo run-up. And so everyone in the study gets placebo for the first couple of weeks. And then people that get better from just the placebo, that is, they report their depression gets better, are eliminated from the study because they're obviously responding to the placebo. And then you have much stronger ability to interpret the results of a drug trial if you do that kind of placebo run-up. So those placebo effects and nocebo effects are quite real. So we use in these kinds of experiments what's called a double-blind procedure in a drug study. And that simply means that the participant in the research study doesn't know if they're on the placebo or the drug, or when they might be on the placebo or the drug. You might switch them out. But more importantly, the investigator doesn't know either. And so you have to use some kind of blinding procedure. So in the experiments I've been involved with, someone else does the blinding. So in experiments we conducted with a drug called midazolam, the anesthesiologist would actually administer the drug. My research collaborators would actually do the blinding. So participant 1 would get midazolam first and saline second, and that information would be in a sealed envelope, and it would just say subject 1, session 1, and I would hand that to the anesthesiologist. They would come back with the drug and inject the participant. And so I had no idea which drug they were on or if they were given the placebo for any given participant in any given session. And again, that's to eliminate the potential that I might bias the procedure in some way. So that's the way we do those kinds of drug studies. So review questions: what are the two main features of an experiment? Of course, they are independent and dependent variables. Think about why random assignment is so useful, and think about why we don't allow people to self-select or allow even investigators to select who gets to be in which part of an experiment. So wrapping up the last couple of issues in psychological research is how we draw conclusions. First thing to talk about is what we call statistical significance. And our conversations about this are ever evolving as we start to use different kinds of statistics. So statistical significance is determined when we calculate the odds that random assignment has failed through inferential statistics. And so we use things like, say, a t-test. So if we have two groups, let's go back to our drug example. We're going to give people modafinil and placebo, and we want to know, is there a significant difference between those? So we test the means of those groups and try to determine whether or not there's a significant difference between those groups. So what we do essentially is we divide the effect, so the difference between those means, by what we call error, and we measure error through variance. And so we use those statistical tests to determine whether or not there's a significant difference. And we're simply trying to determine whether or not any observed difference is real or due to random chance. And so we want to make sure that any effect we have is actually real and not due to just some random chance. So we've decided for some reason that the chance that we have a random effect is okay at 5%. So we want to make sure that there is less than a 5% chance that any observed effect we have is due to just random error rather than to an actual real effect. And essentially you can think of it this way. If we ran the experiment 100 times, 5 of those would come back significant even though there was no real effect. And so essentially if we're going to assume that there's no effect of our drug and we run 100 experiments, our statistics are going to come back that we had a real effect 5 times out of 100. And that's what we've decided is okay. 2 questions to grapple with our conclusions are internal validity and external validity. The internal validity of an experiment is demonstrated by good research methodology. There is a clear established causal relationship between our independent and dependent variable. The external validity of an experiment has to do with the whether or not the experiment might be valid outside of the laboratory. That's why we call it external validity. Sometimes this is called ecological validity. And this is where you have to grapple between having tightly controlled experiments that don't represent the real world in any way versus maybe losing a little bit control and trying to use more realistic scenarios or stimuli. And so this is a grapple. So oftentimes we'll start with a tightly controlled experiment. It probably doesn't have a great deal of utility outside the laboratory. And then we can go out and test it in more applied settings. So we can try to do more applied materials and then maybe even eventually go out to a classroom and try to see how these things work out. So that's an important part of this process. So it's important to first establish internal validity and then try to establish to make sure that our findings actually have some importance outside the lab. A couple of notes on sampling and representativeness. In any experiment or survey, we can't observe an entire population, so we instead have to draw a sample. Our population, to get some lingo out of the way, is a complete collection of participants who might possibly be measured. So first thing we have to do is identify our population. Maybe we're interested in college students, or maybe we're interested in college students at a specific college, or we're interested in men who have sex with men, or we're interested in whoever, but that's our population. Our sample then is the partial collection of people drawn from that population. And so we can't access every person in the United States, we can't access every registered voter in the United States, every likely voter in the United States, so we sample those people in a poll. And experiments are the same way. And we, in general, try to do random sampling rather than things like a case method. Case methods are one way of doing things, but we're more interested in doing things like random sampling. And so this is a technique for choosing participant that ensures that every member of the population has an equal chance of being included in the sample. And this almost never happens. This is kind of pipe dream sampling. What we usually end up with is some sort of non-random sampling. So in most experimental work, we employ participants who get credit in their psychology courses, or we pay them. But we have to make sure that the sample in the population isn't entirely different. So we make sure that we do things like replicate and make sure that we measure to make sure that our sample isn't terribly different from the population. This is something pollsters go to a great deal of work trying to do. They measure things like race, party affiliation, age, previous voting habits, all sorts of demographic variables, because those demographic variables are important to try to determine whether or not their sample matches the population. And so that's a really important thing to consider with research as well. So to give you an idea of how random sampling sampling errors can lead to some errors, of course, the famous Dewey defeats Truman exit poll sample. Same thing in 2004. Exit polls predicted John Kerry would be president again. There you get some selection bias in these results, and that's an important thing to understand. So whenever you're looking at a research study, you always want to think about how do people end up in it. So to kind of summarize, experimental results are particularly good for establishing cause and effect relationships. Correlations are good when you either can't conduct experiments. So, for example, we can't randomly assign people to smoke and not smoke. So you oftentimes have to rely on correlations and multiple regression. Other times you're interested in studying larger scale issues that you can do sort of what we call an interrupted time series design and look at how correlations change over time as policies change. But hopefully you found this an interesting introduction to the ways in which we conduct psychological research.